We're looking at learning target 23 for AP Physics B, which states that students should be able to calculate the work done by a specified constant force on an object that undergoes a specified displacement. So, we're dealing with work, which is a scalar quantity. We've done a lot of vectors lately, so this is a bit of a change for us. Work doesn't have a direction with it. It's calculated from two values that are vectors, though. Work is equal to force times displacement, or delta x is sometimes what we use. At this point, it kind of makes more sense to use just a d for displacement. Because it's probably going to have an x and a y component to it, so we could get confused if we use the delta x there. Now these are two vectors that we're multiplying together. What's really going on is not just multiplication. We call this a dot product of two vectors. Now this is a vector operation that we haven't really worked with before. And we don't really need to know too much about it because we can write this out in terms of the magnitudes of the vectors and the angle between them. Work is equal to force times distance times the cosine of the angle between the force vector and the distance vector. So we know that, that when we calculate work, we're looking at some force that we're applying to an object. It has to move some distance, so if you push on some big heavy table and the table doesn't move at all, then the distance is going to be 0, so we've done 0 work there. But we also can think about trying to push alongside a car, run alongside a car and push it perpendicular to the direction of the car's motion. And so it wouldn't make sense to talk about the work we're doing there because, yeah, the car's moving, yeah, we're applying a force, but the car's moving because of the forces from the engine, and we're not really having much of an impact there, if any noticeable impact. So we just look at forces that act along the same direction, or it could be in the opposite direction as the distance vector. So let's do an example here. We'll say that we have a box. It's a 2-kilogram box, though you'll notice that the equation doesn't have m in it, so it doesn't matter what the mass of the box is. We're going to apply a 10 Newton force to it, and it's going to travel a distance of 15 meters to end right here. Okay, so it's moving over to the right. The force we apply is over to the right. So those are in the same direction. So theta is a measure of the angle between the force and the distance vector or displacement vector. So the angle here is just going to be 0. Cosine of 0 is just 1. So work is equal to 10 newtons times 15 meters or 150 joules.